Good morning. My name is Abdul Wasim. I have completed my MSc and BA from Osmania University, and MSc I done from Nagarjuna University. Today, I would like to take a small, simple lesson on physics. So let's begin with the topic. Today, I will be explaining about the sound. You will be hearing different types of sound in your surrounding. So there are various types of sound which you will hear in the day-to-day life. You will be hearing right from the beginning of the morning till you get in the night. You will be hearing different kind of sound. So if you study what is called a sound in physics, so what do you define? How do you define a sound? Sound. How does sound is formed? Generally, what do you think? How the sound is produced? So we know that when you produce sound, that means what actually happening there, the sound is produced when a body is set into vibration. So here, sound is a form of energy which is produced when a body is set into vibrations. So sound is a form of energy produced when a body is set into vibration. Any kind of body, like if you have an electric bell in a house, it is producing the sound by vibrating the object. If you hit the bench, it will be producing the sound by vibrating the object. Similarly, sound also produced in different media like solids, liquids, as well as in gases. And sound can also be propagated in different media, solid, liquids, as well as in gases. So today we will discuss about how the sound is produced and how it is propagated in the medium. So we have different examples we can take. The first example I would like to take here is about the tuning fork. You will be seeing a tuning fork will be just like this, which is used in the laboratory. We call it as tuning fork, which is having a certain frequency. This is having a certain frequency. Because of that, it will be vibrating. So here, if you have a rubber hammer, we take a rubber hammer and hit this rubber hammer on the prongs. This is called prongs. Okay, and this is the stem of the tuning fork. So when you hit this with a rubber hammer, it will be vibrating, to and fro motion. The to and fro motion of an object is called as oscillation. The to and fro motion of an object is called as oscillation. So oscillations are produced when you hit this on the prongs. So it will be vibrating. So to and fro means moving forward as well as in the backward direction. So in this way, the sound is produced when you hit the hammer on the prongs. So sound is propagated and moved in the forward direction. So here, what is the medium we have? The medium is A. A is the medium in which the sound is propagated. So let's see here how and what happens when the propagation of sound takes place in the medium A. This is the medium A in which the particles, when they hit together, it will pushes the neighboring particles. It will pushes the neighboring particles next to the other particles and then next to the other particles. In this way, what happens? The sound waves will be propagated and move in the forward direction. Here, when it hits the forward particle, the particles, it will be moving. Means it is hitting the neighboring particles and making them to move in the forward direction. In this way, it will move by forming compressions and rarefactions by pushing the particles together. So, and for suppose example, let us consider an example. If you're standing in a long queue, a person is standing at the back. Okay, a person is standing at the back. It pushes the next person. The next person pushes the next person. In this way, the disturbance will take place in the queue till it reaches the other end. Just like that, here also, the particles of A pushes the neighboring particles so that the A pushes together, the particles will come closer, where the density will be increases, the pressure will be increases, forming compression. Similarly, when they move backward direction, so they will be moving in the backward direction, then the pressure and the density will be decreases, and thus causes the rarefactions. Compressions and rarefactions constitute a wave, and in this way, the waves are propagating in the forward direction and moving to form compressions and rarefactions. C is for compression. C is for compression and R is for rarefaction. So in this way, the compression and rarefaction is constituted in a wave. It constitutes a wave by forming compressions as well as rarefactions. A compression and rarefaction constitute a wave. Okay, so here if you take in the waveform, here the wave will be just like this. Here the particles which are in the compression form will be having the crest, and the particles which are forming in the middle, that is trough. Okay, a crust and a trough constitute a wave. A crust and a trough constitute a wave. In this way, the formation of the waves will take place. So this is the best example. We can take the sound waves propagated in the medium A, moving the forward direction, forming compressions and rarefactions. During the compression, it forms higher density and higher pressure, whereas in the rarefaction, the density of the air or the density of the particles of the air will be less and the pressure also less. So it forms rarefaction. So compressions and rarefaction constitute a wave. Now, during this wave propagation, what actually happens? The particles will be in the same position, just vibrating in the mean position, and the energy is carried out in the forward direction. Okay, and forming a longitudinal form of wave. So sound waves are basically longitudinal form of waves because they are propagating compressions and rarefactions forming in the medium A. So the mechanical waves are produced. Mechanical waves are nothing but these are longitudinal mechanical waves. So here longitudinal form of waves are produced in the medium A. So what do you call a mechanical waves? Mechanical waves are those waves which are having a medium for its propagation. Sound requires a medium for its propagation. Sound cannot propagate without the medium. So here we have crest and trough constituting a wave, compressions forming crest and rarefactions forming trough, upward peak, crest and downward depression, trough. Compression and rarefaction constitute to form a wave. This is called longitudinal form of wave. The other examples we can take a slinky on which the sound waves are produced. This is another example we can take. Longitudinal form of waves like A, in which the sound waves are propagated. Okay, this is also a longitudinal form of wave, but the sound requires a material medium for its propagation. Similarly, if you take three different substances like solid, liquid, and gases, if you take solids having more propagation of sound, where the particles are closer to each other, they transfer the energy very fast. The transformation of energy is very fast. Why? Because all the particles are closer to each other. Whereas in the liquids, the particles slightly apart from each other. Whereas in the gases, the particles are very far away from each other. So if you consider solid, liquid, and gases, in the solids, the propagation of sound will be very high, whereas in the liquids, it's in between solids and gases. But whereas in the gases, the propagation of sound is least. So we can say the velocity of sound. What would be the velocity of sound in A? The velocity of sound generally at 0 degrees Celsius, which will be 331 meter per second. This is the velocity of sound. Okay, and the velocity of sound in medium air at 45 degrees Celsius, 341 meter per second. So from this we can understand that as the temperature increases, the velocity of sound also increases. As the temperature increases, the velocity of sound also increases. So this is one important thing we have noticed. In the solid, liquids, and gases, solids will have the highest velocity. That is, for example, if you take an aluminium, it is approximately 1500 meter per second. Okay, whereas in the water, it is quite lesser than this. It is 1200 or 1000 sometimes, based on the liquid which we use. And in the gases, it will be 331 or 341 based upon the temperature which we have. So as the temperature increases, the velocity of sound also increases. So here from all these things, we have understood that the sound requires a material medium for its propagation. Without a material medium, the sound cannot be propagated. So it's very important to notice that sound requires material for its propagation. Sound waves are longitudinal form of waves. The highest velocity of sound will be in solids, and the least will be in the gases. So this is the things which we have discussed today, and in the next class we will be discussing some more points. Till then, goodbye.